Alright guys, so today's lesson is going to be asynchronous instead of synchronous. So synchronous is when we do it live, asynchronous is when I record them. So today we're going to be adding mixed numbers, chapter 9 still, lesson 11, starting on page 677. We're going to go all the way to 682. I got pen on my finger. Alright, so here we are with this hammerhead shark. He has a little idiom here. Let's hammer out the answer. So if you hammer something out, you come to a solution. You could do it like with if you're having an argument with someone, right? You disagree on something. You can hammer out a solution. So we're going to hammer out a solution, an answer to this math problem. So here's a hammerhead shark, right? They're doing a play on words. He swam 2 1/4 miles, 2 1/4 miles. The next day, it swam 1 1/4 miles, right? I'm putting an S because it's more than 1. It's not 2, but it's more than 1. How many miles did it swim altogether? So I have 2 1/4 plus 1 1/4. Very nice here, right? I have like denominators. They're the same. So I have 2 1/4 plus 1 1/4. I'm going to do an approximation. This is a unit fraction, right? Unless it's 1/2, I'm not going to round up if it's a unit fraction. So this one's not. So let's just round down to 2. And we're going to round this one to just 1. They broke my 2 up into 2, right? This is 2 still. 1 plus 1 is 2. Plus my quarter plus my 1 plus my quarter, right? We remember doing this. We've done this before. We can take numbers like 236. And I can write this 200 plus 30 plus 6, right, using my place value. This is how much is in the ones place. This is how much is in the tens place. This is how much is in the hundreds place, right? There's 2 hundreds, 3 tens, 6 ones. So that's all they did here is broke this problem up. All right, so now we're doing our commutative property of addition, right? In addition, I can move numbers around and I still get the same answer. So we're going to move all our ones together. 1 plus 1 plus 1, and we're adding our 1/4 plus our 1/4, right? So 1 plus 1 plus 1 is 3. And 4, my denominator is still 4. I add the numerators, 1 plus 1, 2. So my answer is 3 and 2/4. So I have to remember to write 2/4 in my simplest term. I didn't do that. Sorry. Oops. I forgot one thing. Oh, right. My brain's going, oh, I can't leave it like that. I see both of these numbers can be divided by, they have a common factor of 2, right? 2 times 1 is 2, and 2 times 2 is 4. So I'm still going to keep my 3 just like it is. And I'm going to do 2 divided by 2 is 1. Maybe you already did this in your box over here. And you're like, you read the directions over here. Or you can add it on like that if you're just copying me. So the hammerhead shark swam 3 1/2 miles with an S. Here's the model, right? That's what it's showing me. 1 plus 1 plus 1 plus the 1/4 plus the 1/4, right? 2 more quarters, I would have had another 1 whole mile. Compared to the estimate, remember our estimate was 3 1/2. Is it about 3? Yeah, it's about 3. I would round this to 4 though, right? Because it has 1/2. That's the only unit fraction. I would round this up to 4. The answer is reasonable. Yep, we just checked our answer one way with drawing our pictures using our manipulatives. Alright, the diagram shows the length of the sea turtle. Oh, we have an ocean theme today. What is the total length of the sea turtle? Alright, so, because they're measuring him in little pieces. They're measuring from his tip of his shell to the tip of his shell, and then from his shoulder to his tip of his nose, and then they're measuring from the tip of his shell to how far back his foot reaches. So they're measuring him in 3 different parts. I guess they couldn't just take the tape measure, right? They had to measure in pieces. So, we're going to add up 3 numbers. Woohoo! 7/8 plus 3 1/4 plus 1 1/8. Well, hopefully you see something that, right, these have in common. They I'm going to find my least common multiple, right, that they would have. I always get these terms all mixed up. Sorry, hopefully I said that the right one. So, I know my least common multiple of these numbers is 8. I can turn a 4 into an 8 pretty easy. So that's what we're going to do right here. I'm going to take my 3 1/4 and I'm going to change it. I'm not changing it into anything except for an equivalent fraction. It's the same number. It's just cut up in smaller pieces. So my 3, I'm going to leave a 3. My 1/4, though, I'm going to multiply times 2 times 2. So now I'll have 3 and 2 8s. Now I can add them all together. So now we're going to do 7 8s. That's his toe. That's how much that is. 3 1/4 and 1 1/8. I did my 7 8s again. My 3 1/4 I changed into 3 2 8s. And then I add my 1 1/8. So that's what they're saying we did here, right? We switched our numbers over. We just switched that one for that one. Now I'm going to use my commutative property of addition and move my numbers around, right? I'll move my whole numbers together. So I have a 3 and a, sorry, I'll do this one over here. Sorry, we have a 3 and a 1, 3 and a 1, 7 8s, 2 8s, 1 8, right? We grouped them all together. Now I do 3 plus 1 is 4. Now I do my 8s, right? They're all going to be 8, 8, 8, 8. My denominator has to be 8. It has to stay the same. I only add the numerators. I'm going to add 7 plus 2 plus 1 and get 10. 10 8s. Hopefully your brain's going, no, I can't have a fraction with the number, the numerator larger than my denominator, right? This is an improper fraction. All right, so we're going to fix this. Hopefully you could see 10 8s would be the same as 8 8s plus 2 8s, which would be 1, because 8 over 8, 8 out of 8 is 1 whole pie, 1 whole pizza, 1 whole cookie. And my 2 8s is still a part of it, right? I can also do this with math. I can just say 10 divided by 8. I know there's a lot of ways I could do it. Can 8 go into 1? No. Can 8 go into 10? Yes. How many times? 1 time. 1 times 8 is 8. Subtract. Right? I can't subtract from 0. 8 take away 0, but I could borrow from here and turn it into a 10. Or you could just see I did have a 10 with nothing in the tens place here, so I could have just left my 10, subtracted 8. Right? We don't know. Oh, it's so hard to do, but you can just add what? Plus 8 is 10. 8 is in my head. 9, 10. 2. I have 2. 2 is going to be my numerator. 8 is going to be my denominator. And hopefully you can see, 2 8s, we can definitely make that smaller. So that's what we're going to do in our next step right over here. We're going to, I'm debating how we should write it. Let's just write it the way we had it right here. We'll do 4 plus 1, right, is 5. And 2 8s. And we'll reduce it in the next step, okay? So now I'm going to change my 1 and 2 8s. Sorry, I'm like, where should I? I'm just going to do it right here. I have to change my 2 8s, right? My 5 and 2 8s. I'm going to change my 2 8s. I see they have a common factor, right? 2 can be divided by 2. 2 times 1 is 2. 8 can be divided by 2. 2 times 4 is 8. So now I'm going to have 2 divided by 2 is 1. 8 divided by 2 is 4. So now instead I'm going to have 5 and 1/4. So now we'll write it in this box. So 7 8s plus 3/4 plus 1 8 equals 5 and 1/4. The total length of the sea turtle is 5 and 1/4 feet. Alright, that is my plural. 1 foot, 2 feet. Alright, so here is my next one. Estimate. Yay! Then add. We're going to do real adding. Write the sum in simplest form. So first we're going to estimate, though. 3 and 3/8. Right, so I'm going to see what's a half. 4 8s is 1/2. So I am not going to round this up to 4. I'm going to leave it a 3. I'm doing my estimation. And this 2 and 1/2 is already a half, so I'm going to round up to 3. It has to be 1/2 before I round out. So this is 6. So I could say this is about going to be 6. That's my estimate. We're going to find the real answer though. Alright, so they have 3 3/8 plus 2 1/2. They changed the 1/2 into 4/8 already for me. So, right, in my next step here, there's the 3/8, there's the 1/2. They already switched it for 4/8 for me. They took the 3 and they broke it up into ones. 3, 1, 2, 3. They took my 2 and broke it up into ones. 2, 1, 2. Right, there's the 3/8, there's the 1/2 as 4/8. Now we're going to add it all together. So I'm going to count 1, 2, 3, 4, 5. And I'm going to do 8, 8, 8. 3 plus 4 is 7. I add my numerators. 5 and 7/8. Is that close to 6? Yeah. I checked it even. Next problem. Oh. Explain how to simplify 3 6/4. Right, we have to change this. It is an improper fraction. So I could do it a bunch of different ways. So can we say we're going to take the 6 and the 4, and we're going to figure out what whole number I could add here, right? 4/4 would be 1. And what would I add to 4/4 to be able to get 6/4, right? I'm doing backwards addition. 2/4. So I'm going to say 6/4 is equal to 1 2/4. Oh, but we can't stop there, right? I see they have a common factor. 2 can go into 2 and 2 can go into 4. 2 goes into 2 one time. 2 goes into 4 2 times 1/2. So I have, oops, I should have put my 1 in there somewhere. 1 1/2. I need to write it in the front. I don't write it in the back. 1 1/2 for the guy there. So now we have to do 1 1/2 plus the 3. So after I do that, I'm going to add it. So 3 plus 1 is 4 and 1/2. So 3 6/4 equals 4 and 1/2. Right? When you write problems like this, people are like, what? If they don't know fractions. But you do, so you'll be all, easy peasy. No, it's not easy. I know. Alright, so we're going to add these two together. I have 2 whole numbers and 2 fractions. They have like denominators, so I'm good there. 4 plus 3, I'm going to add that, is 7. 5, 5, 5. My denominator stays the same. 3 plus 1 is 4. I can't make that any smaller. It's going to stay like that. Alright, next one. 7, 2, 4 11ths, 6 11ths. Oh, I have my common denominator, my like denominator. Alright, so 7 and 2 is 9. I have my denominator, 11, 11, 11. I'm going to add my numerators, 6 plus the 4 is 10. I can't make it any smaller. I can't reduce it. Simplest form. Right, we always have to make sure we're doing simplest form. Alright, next one. Oh, I see already something I have to fix here. Something I have to work around. I can't add a 12 and a 4th, a 12th and a 4th. I'm going to change my 4th into a 12 by multiplying times 3 times 3. So now this is going to be 3, and this is going to be 12 on the bottom. Now we can add 5 plus the 6 is 11. I'm going to make my little fraction line. I know my denominator is going to be 12, right? 12, 12, 12. And I'm going to add the numerators. 1 plus 3 is 4. But we can't stop there, right? I have a common multiple here. Sorry, a common factor. I have to find my least common factor, my greatest common factor. Yeah, my greatest common factor. I'm going to divide by 4, right? Because 4 times 1 is 4, so it is a factor, right? When I multiply 2 factors together, I get a product. So I'm finding my greatest common factor. 4 divided by 4. I'm reminding myself just as much as you guys. All right, 4 divided by 4 is 1. 12 divided by 4 is 3. So my answer, I'm going to write it again nice and neater. 11 and 1/3. Next problem. Oh, nice, I got my 15. 15. All right, so 8 plus 3 is 11. I'm going to write my fraction line, put my denominator. 15, 15, 15. 4 plus 2 is 6. But we can't stop there, right? There is a common factor here, 3. Right? 3 can go into 6 and 3 can go into 15. So divide by 3, divide by 3. I'm going to have 6 divided by 3 equals 2. 15 divided by 3 equals 5. So I will have equals 11 and 2/5. All right, my next one. I see a 9 there and I see a 3 here. I can turn my 3 into a 9. I'm going to multiply times 3. I'm going to write it on this side. Times 3. I'm going to multiply times 3. 3 times 1 equals 1. 3 times 3 equals 9. So now I have 1/9. So we're going to have 6 plus 2 is 8. I'll draw my fraction line. I'm going to go 9, 9, 9. And 1 plus, sorry, did I say 3 times 1 equals 1? 3 times 1 equals 3. 1 plus 3 is 4. See, you always got to be watching yourself. All right, so here, next problem. Oh, unlike, doubly unlike, right? But I see a common, I can cheat, right? And say, just multiply these two together and get 6, which is my other one too. My least common multiple between the two of these numbers is 6, right? I count by 3s, 3, 6, 9, 12. I count by 2s, 2, 4, 6. They're going to have more numbers in common, but the smallest one is 6. So, turn this into a 6. Whatever I do to the bottom, I have to do to the top. Turn this into a 6. Whatever I do to the bottom, I have to do to the top. 2 times 1 is 2. 2 times 3 is 6. 3 times 1 is 3. 3 times 2 is 6. So I have 2 6 plus 3 6. I have my 5 plus my 6. 11. And I have my 2 plus my 3. Oh, sorry. First things first. 6, 6, 6, my denominator. And I'm going to add my 2 plus my 3 and have a 5. Right? If I was estimating, I could see over here, I'm not even going to go there because I'd probably do 12. I would have estimated 12. But it's close to 12. Right? 5 1/3, I would round it to 5. 6 1/2, I would round it up to 7. And 11 5 6, and 5 6 is almost 12. All right. Next one. Oh, they lined it up for us this way. I kind of like it when they do it this way. All right, let's see. 9 and a 3 in the denominator. Let's change this 3. So I'm going to multiply times 3. So this is going to be 3 times 3 is 9. I'm going to multiply the top times 3. 3 times 2 is 6. 6/9. So now I'm going to add my 3 plus my 4. 7. I'm going to draw my fraction bar there. 9, 9, 9. In German, 9 means no, so I'm laughing to myself. Sorry. 6 plus 4 is 10. But we can't stop there. 10/9. I can't leave it like that, right? There's a few different ways I could do it. I could take 10/9 and figure out a backwards addition problem, right? Because I know 9/9 is going to be 1 whole. So what would I add to 9/9 to get 10/9, right? 9, 9, 9, 1 plus 9. So over here now, I'm going to change my 7. I'm going to add my 1 to it. So now I'm going to make this equals 8. And I can't forget my 1/9. 8 and 1/9. All right, next one. 4 and an 8. Let's change that 4 into an 8. 2 times 4 is 8. Whatever I do to the bottom of a fraction, I have to do to the top. So 2 times 3 is 6. Now I can add. 6 plus 3 is 9. Okay, here's my 8, 8, 8. 1 plus 6 is 7, 9 and 7/8. And same thing, if I was going to round here, just if I wanted to check this before I was even adding it to see what it's about, approximate, 6 3/4 is very close to 7, right? It's almost 7. One more fourth and it would be 7. 3 1/8 is closer to 3. It has a unit fraction right there, 1/8. 7 plus 3 is 10. And 9 7/8 is very close, is almost 10. Right, this would just be my little checking it. Oh, because we were supposed to do that anyway, right? We were supposed to estimate all of them. Sorry. All right, let's estimate this one. 4 3/7 plus 7 1/2. So 3/7. So I one of the things I like to do, if I can't figure out 3/7, I'll double this. Right, I'll say 3/7 is the same as 6/14. Right, and I know a half is 7/14. So I know that this is less than a half, so I'm going to leave this at 4. And over here, 7 1/2, I already have the 1/2, so I would round this up to 8. And I'd say 4 plus 8 is 12. So first I'm estimating. Right, here's my, this is almost, and I'm adding those together. All right, 4 3/7 and 7 1/2. So I got to figure out my least common multiple, right? I'd count by 7s. 7, 14. I'd count by 2s, right? That's what they'd have in common. 2, 4, 6, 8, 12, 14. So they both could be changed into a 14, right? My little trick would work too. If I just took the denominators and multiplied them by each other, 7 times 2 is 14. So I'm going to say here 7 times 2. And I have to do the same thing to the top, right? I multiply them, the top and the bottom, by 7, because 7 over 7 is 1. It's just like I'm multiplying by 1. And 1 times any number is the same number. So 7 times 2 is 14. 7 times 1 is 7. Sorry, I remember that some of you guys told me you couldn't hear me well in the videos. So I was trying to remember to put my microphone up when I was doing videos. Now all of a sudden you're like, oh, you could probably hear me good. Or maybe not. I don't know. Anyway, hopefully you could hear me okay, or at least you're just watching and doing your math with me, and maybe it's better like that. All right, so I forgot where I was at. Oh, I'm turning this into 14s, right? I'm turning my fractions into an equivalent fraction, so I have to change this one into a 14, so I'm going to multiply times 2 times 2. 2 times 3 is 6. 2 times 7 is 14. Now I can add. All right, 4 plus 7, it's all jumbly munchied under there, huh? 4 plus 7 is 11, and I'm going to add my fractions. 14, 14, 14. 6 plus 7 is 13. Let's see, 11 and 13 14ths is almost 12. Look, and I wrote the 12 right there. All right, next problem. I always want to write in pencil. And you should be writing in pencil. But I know you guys can't see well when I write in pencil. It's just very faint. How about if I do in green pen? Maybe that will help. All right, let's try that. Okay, 9 and 9/10 plus 7 and 3/5 equals y. Y, right here. All right, so 9/10 plus 3/5. I can see here, I can change my 5 into a 10 if I multiply times 2 times 2. So now I have 2 times 3 is 6, and 2 times 5 is 10. Now I can add, right? I have 9 plus 7 is 16, and I'll add my fractions. 10, 10, 10. I'll add the numerators. 6 plus 9. So 6 plus 9 is 15. And hopefully your brain's like, wait, 15 tenths. We cannot leave it like that. We need to put it in simpler terms. It's an improper fraction. So I'm going to change this, fix it. All right, so 15 tenths. I'm going to do a backwards math problem here, right? I know this would be 10, 10, 10. And here I'm going to say 10 out of 10 gives me 1. Right, this equals 1. And 10 plus something equals 15 plus 5 5/10, though. Hopefully you could see that too. 5/10. I know 5 can be divided by 5, and 10 can be divided by 5. So I found my greatest common factor of these two numbers. 5 divided by 5 is 1. 10 divided by 5 is 2. So, oops, sorry, I keep forgetting to put my 1 in there. 1 and 1/2. Now I have this is equal to 1 and 1/2. So now I'm going to add my 16 to my 1. So I'm going to have 17 and 1/2. I can't forget my half. All right, we weren't supposed to estimate, but I could, but then these videos get so long. Sorry. Okay, so 20 and 4. Hopefully you see you can turn your 4 into a 20, because I know my math facts. 5 times 4 is 20. Whatever I do to the bottom, I have to do to the top. 5 times 1 is 5. All right, I'm going to find K, so I'm going to add 14 plus 8 is 22. I'm like hesitating. Wait, is it really? Yeah. And 20, 20, 20. And now I'm going to add my 5 plus my 19. So I have 24. And it's an improper fraction. So I don't know which way to do it. We could do it this way. I like doing it the other way so that we practice our division. So 20, 20, 20. I'm doing a reverse addition problem. 24. Right, I'm going to turn this into 1. Here's my 1. 24 is 20 plus 4. So this is equal to 1. I remember to do my 1. And I'm going to take my 420 and reduce it. I can divide the top by 4 and the bottom by 4. This is equal to 5. This is equal to 1. So 1 and 1/5. So now I have 22 and 24/20 is equal to 22 plus 1 is 23 and 1/5. Right? If I was going to round this number, I would round it to 23 because I have a unit fraction here. It's very small. I would round this to 23. All right, my next one. Last one on this page. 12, 3. Let's change that 3 into a 12. Let's multiply it times 4 times 4. So this is going to be equal to, oops, 4 times 2 is 8. 4 times 3 is 12. So 16 plus 5 is 21. I'm going to add 12, 12, 12. 11 plus 8 is 19. Hopefully your bells in your head's going out. We can't leave 19 twelfths. So let's do 19 twelfths equals a reverse addition problem, right? 12, 12, 12. 19 is 12 plus 7. So now I have this is equal to 1 and 7/12. I can't make 7/12 any smaller. There's no number that goes into 7 and 12. So this is equal to 21 plus the 1 and 7/12. If I go too fast, just pause it. Alright, on to the back. Alright, here's Zeta. She made 1 5/8 quarts of punch. Then she made 1 7/8 more quarts. How much punch did she make in all? So my little math fact of the day is, if you're measuring, did you know 4 quarts is equal to 1 gallon? Right? Just like 4 fourths and a quart, quarter, cuatro, 4. Anyway. Zeta made this much punch. Then she made more. How much punch did she make in all? Right? I know I'm adding here because they said in all. So I'm going to add my 1 plus my 1 plus my 5/8 plus my 7/8. Let's do it the way they did their problems earlier. 1 plus my 1 plus my 5/8 plus my 7/8. All right, my 1 plus 1 is 2. I'm going to do add my fraction together. 8, 8, 8. 5 plus 7 is 12. So let's go do our work over here. We have a nice space to do our work right now. So 12 eighths. I'm going to do my reverse addition problem. 8, 8, 8, 8, 8. Right? 8 eighths, so I got my 1. And 8 plus something is 12. Plus 4. So this is equal to my 1 and 4 eighths. And hopefully you're saying, wait, wait, wait. Don't stop yet. Divide by 4, divide by 4, and I have 1. 4 divided by 4 is 1. 8 divided by 4 is 2. 1 half. So I have 1 and 1 half plus my 2. Right? Don't forget your 2. I just fixed my 12 eighths. 12 eighths is now equal to 1 and 1 half. So I'm going to add my 2 plus my 1, and I will have 3. And don't forget your half, and don't forget what you were measuring, quarts. I would round this up to 4 quarts, and I would say I had 1 gallon of punch. She almost has 1 gallon of punch. All right, so find 5 and 2 eighths plus 3 and 6 eighths. Write in words in simplest form. So we're going to find our math problem and then translate it into words. All right, so fun is this one. 5 and 2 eighths plus 3 and 6 eighths, right? I can't add words, but I can do this. 5 and 2 eighths. I could do it in my head too, but let's do this. It's more fun. Plus 3 and 6 eighths. We're going to add together. So 5 plus 3 is 8. And now I'm going to add 8, 8, 8. I'm going to add my fractions. 2 plus 6 is 8. Ha! 8, 8, 8, 8. Right, I could write my answer as 8 and 8 eighths. Or we could do this. This is equal to 1. This is equal to 9. So my answer is 9. That's in its simplest form, right? It did tell me to write it in simplest form, which would be 9. There's my answer. All right. Tomas made fruit salad using the recipe. How many cups of fruit are needed all together? So we have to add up these 4 fruits here. So let's do it like this. We're going to add up our 3 plus our 1 plus our 1 plus our 2, right? They gave us a little baby spot right there. So 3 plus 1 plus 1 plus 2. And now we'll add our fractions. 1 half. Oops, I should need a plus. Sorry, it's way past my bedtime. All right, so 1 half. I'm going to change my 1 half, right? And I was doing my plus and thinking at the same time, right? I'm not going to do 1 half, right? I need to change it to a 4. I got 4, 4, 4, 4, and just this 1 half. So hopefully, right, you guys remember now 1 half is equal to 2 fourths. I multiply the top times 2. I multiply the bottom times 2. Oops. And then I have 4. Sorry, you can't even read that. But and the bottom times 2. And now I'll have 2 fourths. So instead of writing 1 half over here, I'm going to write 2 fourths plus 1 fourth plus 3 fourths plus 1 fourth. I'm going to add my whole numbers, right? 3 plus 1 plus 1 plus 2. So I'd probably go 2 plus 1, I'd go backwards, right? 2, 3, 4. 4 plus 3 is 7, right? Or you could go 3, 4, 5. 5 plus 2 is 7. Add our fractions. We're going to have 2 plus 1 is 3, 3 plus 3 is 6, and 6 plus 1 is 7. So I'll have 7 and 7 fourths, which is not in my simplest form, right? So I'm going to fix 7 fourths is equal need my 1. And something plus 4 is 7. 3 plus 4 is 7. So I have this is equal to 1 and 3/4. So I'm going to take my 1 and add it to this 7. So I'll write my equal sign right here. Equals, altogether I have 7 plus 1 is 8 and 3/4. Almost 9 cups of fruit. This, oh, can't forget that. Right, C stands for cups when I'm cooking. All right, and here is Antoine is finding 4/5 plus 2 and 3/5. Find and correct his mistake. So let's see what he did. He wrote 4 and 1/5. He did that right. 2 and 3/5. He did that right. He added 5 plus 5 is 10, and he added 1 plus 3 is 4. Right? Oops, sorry, Antoine. He added the fraction incorrectly. So let's fix it for him because it said to find and correct his mistake. So let's just do it like this. We'll say 4 and 1/5 plus 2 and 3/5 equals, we're going to add our 4 plus our 2, 6, 5, 5, 5. 1 plus 3 is 4, 6 and 4/5. All right. How can equivalent fractions help when adding mixed numbers? I can find equivalent fractions to find like denominators when adding fractions. Sorry. Mixed, just kidding, numbers. Oops, so crooked there. I need to write sideways, but you probably don't need to read it sideways. So you can pause it if you need to go back and do any answers. I'm going to record the homework on a separate video.